So we're going to talk about solving one-step equations. One step, they call it one-step equations because it only takes one step to get the answer. It's only one thing you have to do, right? And the other thing that we have to talk about is equations. Because I have not given you equations this year. I have only given you expressions. Mathematical expressions are all the things I've given you without an equal sign, right? An equation has an equal sign, right? Right? It's got it right in the name, an equal sign in it, right? So, and remember yesterday I was doing something and I was showing you something and then I wrote an equation and I thought, oh my God, I haven't taught you how to solve an equation yet. They don't do it in Saxon until lesson 26 and I can't wait, right? So we're doing it now. So solving one-step equation. Now there's three types of equations you might see, but before I even get into that, we have to look at one thing, and it's called the golden rule of algebra, right? The golden
it's over there.
Rule. What? Yes. All right. This is such an important rule. You will be living with this rule for the rest of your life. Whatever. Yes. Whatever. Exactly. Whatever it says. Whatever. What does it say? Do unto one side of the equation as you would do unto the other. You know. Do unto one. One side of the equation as you would do unto the other, something like that. As you would. It sounds so biblical. Do unto the other. In other words, in plain terms, this is really what it means. You can do anything. Anything. Where's your notes? Okay, put the book away and get your notes out. You have to be writing everything I write on this board has to be on your notes. Right? Everything. Okay? You can do anything you want to one side of an equation as long as you do exactly the same thing to the other side of the equation. Right? That's really what it's saying. It's just that's sort of more biblical the way we're writing it. Just because most people know the golden rule, right? Do unto one side of the equation as you would do unto the other. So you always, if you do something to one side, you have to do exactly the same thing to the other side, right? So there's three types of problems that you're going to see. And I'm going to write each one up. You could have x plus 4 equals 10. Another problem you might see would be x, let's see here, 3x equals 9. And a third kind of a problem you might see might be 2/3 x equals I don't know, 4, something like that. 2/3 x equals 4. Each of these problems can be solved with one step. One simple step. Right? Now each step is different in each of these problems. But if you know all of these separately, when we combine them all together, you will know how to solve practically any equation there is. The whole goal is to find out. When you are solving an equation, your goal is to solve for the unknown, right? Right? And the unknown in this case are x's. Now, what is an x? Because I don't know if everybody's been exposed to an x. Right? It's a variable. What more? Say more about it. I mean, because like in math before algebra, it's representative. That's very correct. It is representative of a number. It actually is a number.
Yeah.
The trouble is, what's the trouble? We don't know what the number is.
Yeah,
right?
that's
the trouble. But it is a number, so it behaves exactly like a number, right? Behaves. So have you written all of this, Sevi, in your notebook?
Yes.
Okay, good. I just want to be sure.
Wait, can you give it?
So x is a number, so we can add to it, we can subtract it, we can multiply it, we can divide it, and hopefully we'll eventually come up with an answer.
Can I give all the
Now, I'm going to tell you something. Hang on. I'm going to tell you something that's really very good information. If you have one variable, how many variables do I have in this equation right here? One variable. If you have one variable and one equation, you can always solve for that variable. Now that sounds kind of obvious, right? But I'm going to tell you something. Keep going. If you had two variables, you need how many equations to solve for it? For both of, yeah, you would need two equations to solve for those variables. Let's say you had three variables. X plus y plus z equals 10. You would need to have, there's three variables, you'd have to have three equations, right? So right now, we're only dealing with one equation, one variable, right? Eventually, though, you're going to learn how to solve multiple variables by having more equations, right? Right? They're really easy and they're really fun. Well, they're not necessarily easy, but they're fun. Yes, Thorn.
So when a problem is like x plus y and then equals, it'll always have an equals and then
Yes.
a number, right?
Yes,
Oh, yeah.
exactly.
And
There
then
will
you have to
always
solve.
be an equals, exactly. If there's no equal sign, can I solve it?
No.
There's no way to solve it. I can simplify, but I can't solve. The only way you can solve is if there's an equation, an equal sign. Right? Question?
I
Or
was gonna
comment.
question, I was gonna say how to,
Yeah.
like, you just subtract the, like, number.
Exactly. So basically, let's look at one real fast, one thing. Let's look at of all our operations. We got addition, right? Addition. These are called our operations, right? We have addition, we have subtraction, and we have multiplication, and we have division. I'm just going to simplify. All right. What is the opposite of addition? Oh, so now we're going to say our opposite is subtract, right? And our opposite of subtraction is addition. And our opposite of multiply is divide. And our opposite of divide is multiply. So you have to know those, right? And it makes sense. Logically, it just sort of makes sense. You just sort of intuitively know, well, the opposite of multiply is divide, right?
Yeah.
Right? So what we're going to do to solve this is we are going to do this. We're going to say, oh my gosh, X last night was all by itself. All by itself. And somebody came in here and they added 4 to my X. And boy, was I upset. This is video, right? This is video. I was upset, right? Somebody added 4 to my X, right? Remind me this is a video. I am going to undo that. I am going to undo it. So what would be the opposite of 4? Adding 4. Subtracting 4. So I'm going to put a minus 4 right underneath the plus 4. But what do I have to do? Whatever I do to one side of the equation, I have to do to the other. So I'm going to put a minus 4 under the other side of the equal sign. All right? Does that make sense? Don't do them both on the same side of the equal sign. Violet. Don't do these both on the same side of the equal sign. Right? Okay? Now what do? I have X. And look, those cross out, right? Are you writing this all down, Sevi? Make sure it's all down. All right. Equals. So all I have left is X equals. That's what I'm looking for. I wanted to say X equals. What is 10 minus 4? 6. Now, how many people knew the answer to that question before we solved it this way, right? You didn't even have to solve it this way. You guys all knew that the answer was 6, right?
Yeah.
Right? Am I right?
Yes. Yeah.
All right. I am giving you simple problems for you to practice a process. Because if you know this process, when they get hard, you can still use the process. Does that make sense?
Yeah.
So I know you could do that in your head, but that's not what I want you to do. So when I give you the homework tonight, if you just give me an answer, I'm going to mark it all wrong, and I'm going to hand it back to you and have you do it again for the next night. I do not want to see just an answer, right? Mr. Graham, I don't want to see an answer. I want to see an answer, but I want to see it after I see this. I want to see you doing the opposite operation. I want to see you subtracting 4. Now what if here's 1A. Here's 1A. What if I gave you this? X minus 7 equals 10.
Yeah, but then say if it's an easy one, then can we just
No,
put an answer?
no. I want to see this. I want to see the process.
No, but I mean if it's like 3x equals what?
No, you'll see. You'll see. I'll show you exactly what you need to do. So if this one, what would I have to do? Savvy, what would you do?
Cross out the -7.
So somebody, X was all by itself last week, right? Doggone it, somebody came in and subtracted 7 from my X and I am so upset, right? And so what's the opposite of subtracting 7?
Adding.
Adding 7. So I'm going to just put a +7 here, and I'm going to put a +7 here. I have to make sure my 7s are on opposite sides of the equal sign, and they are. I draw a line, and then I write what's left. X plus nothing is X. These cross out. -7 plus 7 is just 0. So I don't have to write 0. And then equals 10 plus 7 is 17. So, right? Yeah, 17 minus 7 is 10. Makes sense. Good. All right. Now, that's for adding and subtracting, right? So if it was an adding problem, we would subtract. We would use the opposite operation. We'd subtract. If it was a subtraction problem, we would add, right? Does that make sense? Pretty straightforward. What is the 3 doing to the X now?
Multiplying.
Multiplying. Oh my gosh, X was all by itself yesterday.
No, it's not.
And I heard rumor that Diego snuck into the building. And he multiplied my X times 3. And I don't know if it's true or not, but if you guys have any information about this, please let me know after class. Right, so what's the opposite of, if I was going to undo the 3 times, what would I do? Divide. Now, you guys all agree with me that every fraction is a division problem? So instead of saying 3 divided by 3, I could do this, 3 divided by 3, right?
Yeah.
That means divided by 3. 3x divided by 3. But I did that to the left side. I have to do the same thing with the right side. I divide by 3. Boom. So these 3's cross out as to a 1. So that gives me 1x, which is just x. Equals 9 divided by 3, which is 3. One step. Pretty easy. Fist of 5. You're getting it. Okay, last one. Last one. Now, before we get to the answer, let's talk about how to do it. When they are fractions, I want this number in front of the x to be a 1. What can you multiply every fraction by
It's reciprocal.
for it to become equal to 1? You multiply it times its reciprocal. All right?
Or divide.
So who knows what? Everybody raise your hand if you know what a reciprocal is. Don't leave yet. Reciprocal. You turn the fraction upside down, right? Right? So watch this. Now you're going to do 3 over 2, and that's going to be 4 over 1. Write this down. Make sure you're writing this down. Sevi, I can't believe you've written all this down. You haven't. Everything on that board. You cannot do this last one. Everything on that board is in your notes. Okay?
Yeah.
And you have to have me sign off on it, okay? And maybe Evan. Can you just sort of keep an eye? You have to write everything down. You can't space out in my class. So, now I've got to do the same thing with this side. I have 3 halves. Okay? So these, look, 2 goes into 2 ones, 2 goes into 2 ones, 3 goes into 3 ones, 3 goes into 3 ones. That just gives me x is equal to. Now I could just multiply 4 times 3
12.
and over 1 times 2, or I could do my upstairs, downstairs reducing, right? 2 goes into 2 once, right? 2 goes into 4 twice. That leaves just 1s on the bottom, which means I don't need them. 2 times 3 is 6, so my answer is 6. Right? Pretty straightforward.
Yeah.
Fist of 5. Do you guys get it?
Yeah.
All right, so your homework is about to be passed out, and then you guys can go.
Oh,
Wait, this sheet.
is it another worksheet?
It is a worksheet again.
Courtney.
1,
Look at my lovely circle.
3.
Do tomorrow, right?
I feel so gifted.
Guys, if you need it, watch the video game, okay? How long video?
I do have to inspire recording.
Yeah. Whatever's really cool. Read it over again.
Hey, Corn!
Let's just open a unicorn. Alright, just stick it.
Yeah.
No, it's still recording. Jerry. I think it's still recording.
Oh, and that is the end of the lecture. Sorry.